All right, today we're going to be looking at how we measure how much moisture there is in the air. So that's dew point and relative humidity. Dew point and relative humidity. All right, so typically when you're concerned about the weather, probably the two main things you're concerned about is what the temperature is outside, or how warm it is outside, which you measure with either degrees Celsius or degrees Fahrenheit, or you're concerned about how, whether it's rainy or how humid it is outside. That's what we're focusing on today, how we go about measuring that, how we go about measuring humidity. Well, there's two ways that we measure humidity. One thing is called the dew point, and another thing is the percent relative humidity. So what we're going to look at is what they are, and then how we go about measuring them. All right, so first off, dew point, the temperature at which the air is saturated, all right? Now, what it means to be saturated, if something's saturated, that means it's completely filled up. It can't hold anymore. Right? So the dew point is the temperature at which the air is saturated with water, and then condensation or dew forms, all right? So if I were to, like, for example, turn the thermostat down in this room to like 30, and as the air temperature was going down, eventually it'd reach a point where I'd start to notice that there's moisture collecting on surfaces. When that first starts happening, that temperature at which that first starts happening, that means I've reached the dew point temperature. All right, so that's what the dew point temperature means. The higher the dew point means that there's more water vapor in the air. So a high dew point means that there's a lot of water in the air. A low dew point means that there's not very much water in the air. And remember that on station models, this number right here is the air temperature. That number right there is the dew point temperature. So between these two station models, this location has more water vapor in the air because it has a greater dew point temperature. Right? That's the air temperature, that's the dew point temperature. The bigger that number is, the more actual water there is in the air. So that has more water in it than that does. All right, now in this room, if condensation was going to happen, where it would happen is like on the surfaces of the floor and the surfaces of the desk, or maybe the surfaces on the wall. But condensation is also the process that results in the formation of clouds and rain. All right, so when condensation happens up there, there still needs to be a surface for the moisture to collect on. So what the moisture collects on, so what kind of surfaces do we have up there? We have dust particles. There's dust particles in the atmosphere. So what happens is when the air goes down to the dew point temperature, dew or condensation starts to collect on dust particles that are floating out in the air. Now initially, there's just a small amount of water on them, like that. All right. So that's what clouds are made out of. Clouds are not made out of water vapor. Clouds are made out of little tiny liquid drops of water. So condensation happens on those dust particles. We call those dust particles condensation nuclei, right? Because that's at the nucleus or the center of the condensation. But again, initially they start off quite small, and those little water droplets up in the air are what make up clouds. But as time goes by, more and more and more and more and more water collects on them through condensation. And these droplets, they're floating in the air, get bigger and bigger and bigger. And as a result, eventually they get so big that they can't stay suspended in the air anymore. So these droplets fall from the sky. Now, inside every single droplet is at least one dust particle. So when the droplet falls from the sky, it brings the dust particles down with it. So precipitation, rain, snow, sleet, stuff like that, Precipitation removes dust particles from the air, cleaning it, right? Because again, every raindrop has at least one dust particle in it. So when those raindrops fall from the sky, they bring the dust particles down with it. All right. Now, the instrument that we use to measure dew point is something called a sling psychrometer. But we're going to come back to that, how we go about using that in a few minutes, because we also use a sling psychrometer to do relative humidity. And I'll just cover them both at once. So let's go down to this. All right, so dew point, the bigger the dew point temperature, the more water there is in the air. Right. The other way we measure how much moisture there is in the air is percent relative humidity. That's how much the air is filled with water expressed as a percent. All right, so for example, if the air in this room had the capacity to hold 10 gallons of water in it, but it was only holding 5 gallons of water, the air is holding half as much moisture as it could hold. Right? I would say that the air has 50% relative humidity, right? Because the air is holding 50% of the moisture that it could hold. Right? So that's basically what relative humidity is. It's what percent that the air is filled with water compared to what its maximum capacity is. All right. Now, on station models, the closer the dew point and air temperature are, the higher the percent relative humidity. So going back to these guys right here, with this one, there's only a 2-degree difference between air temperature and dew point. This one, there's an 11-degree temperature difference. So this one would have a higher percent relative humidity than that one does. Dew point equals air temperature. Relative humidity is 100%. All right, so this guy right here, since the dew point and air temperature are the same number, that means the air is completely saturated with water. The air cannot hold any more water in it. All right. So this one is the one that's the driest. It has the lowest percent relative humidity, and this one would be 100% relative humidity. All right. Because the air temperature and dew point are the same. All right. Let's say that I had a station model that looked like this. All right. Where the air temperature was 40 and the dew point temperature was 45. All right. What that means is that the person who drew the station model doesn't know what they're doing. All right. The reason being is the dew point cannot be higher than the air temperature. All right. The dew point cannot be higher than the air temperature. Kind of think as like the air temperature as being like the size of the container, and then this is how much water is actually in the container. So like, this was a 40-gallon container, and I put 29 gallons in it. That'd be like 73% filled, right? If I had a 40-gallon container and I put 38 gallons in it, it'd be 95% filled. If I had a 40-gallon container and I put 40 gallons in it, it'd be like 100% filled. If I had a 40-gallon container and I put 45 gallons in it, that's impossible. You can't get 45 gallons to a 40-gallon container. Right? So you can never have a dew point greater than the air temperature. So that is wrong. You can't have that. All right. Now, one thing that makes percent relative humidity kind of inconsistent, though, is that air can hold different amounts of moisture at different temperatures. Warm air can hold more moisture than cold air can. So warm air is like having a bigger container. Cold air is like having a smaller container. And I'll show you what that means in a bit. Last thing I'll point out with the notes, the closer the air temperature and dew point are, the better the chance of rain. So like this guy right here, because those two numbers are the same, this one's got the best chance of rain. These two numbers are pretty close, so that one that's the best chance. That's a pretty good chance of rain. And this one, since those two numbers are farthest apart, the air temperature and the dew point, that has the least chance of rain. So the closer the air temperature and dew point are together, the better the chance of rain. All right, well, let's focus back on this, that warm air can hold more moisture than cold air can, all right? And I'll do a little demonstration to kind of show that. All right, so air can hold a certain amount of water, just like this beaker can hold a certain amount of water. All right. So what relative humidity is would be like describing what percent this container is filled with water. So if I was looking at this, I might say this container is, maybe like 40% filled with water. Right? So 40% relative humidity. All right. Now, if I take air and I heat it up, right? Warm air is like having a bigger container because warm air can hold more moisture than cold air can. So if I took this air and I heated it up, it's like switching it to a larger container, right? Now, if I was going to describe what percent this container is filled with water, I might say it's like 10% filled with water. Now it's still technically the same amount of water, I just moved it to a bigger container. So that's basically what happens when you warm air up, is the air feels drier because it's like having a bigger container. The air is filled with a smaller percent of water, but it's actually still the same amount of water, it's just in a bigger container. So that's what happens when you heat air up. It basically, the percent relative humidity goes down because it's like having a bigger container, all right? So let's go back to my starting container, all right? Now, let's say I took the air and I cooled it down, all right? Cold air can hold less moisture than warm air can. So if I cooled it down, it's like moving it to a smaller container, all right? So now, instead of being like 40% filled, I might say it's like 80% filled. Right? Again, still the same amount of water, but it's because the air cooled down, it's like moving it to a smaller container. So the percent relative humidity, the percent of the containers filled with water is more because it's a smaller container. So that's basically what happens like during the course of the day. A lot of times, like your relative humidity during the day, in the morning it feels really humid outside, and then during the day it feels drier, and then in the evening it feels more humid again. When in fact the actual amount of water in the air didn't really change that much. It's because in the morning, all right, it's cooler, so you might have the air is might be 90% filled with water, so it's a high percent relative humidity. But as the day progresses and it gets warmer outside in the afternoon, it's hotter, so it's like having a bigger container. So I went from like 90% humidity, down to like 15% humidity. And then in the evening, when it gets cooler again, it's like switching back to a smaller container. Now I'm back to 90% relative humidity. So that's why it feels damp in the morning and the evening, but it feels drier during the days. A lot of times it's a similar amount of water, but it's just that the air is warmer, so it feels drier because the air could hold more moisture. Now, how you get rain from low pressure and rising air. Okay, so remember that the low pressure means the air is rising. And also remember, whenever air rises, the higher up it goes, the cooler it gets, all right? So let's say I start off with some air at the Earth's surface, and the air's maybe 25% humidity, and the air is rising, right? So as it's going up in elevation, what's going to happen is as it goes up, the air is cooling, so it's like switching it to a smaller container. So now I might have like 70% humidity. As the air goes up even more, it's like switching it to a smaller container yet. And what's going to happen is the container is going to be so small that it can't hold all that moisture. So the excess moisture comes out as rain. All right. So that's what happens when air is rising. That's what happens when air is rising. That's why you get clouds and rain, because it's cooling down. The container basically is getting smaller. eventually you reach the point where it can't hold all that moisture, then the moisture starts to come out, all right? Now, with high pressure, that's sinking air, right? Now, what happens when air sinks? Well, the type of air that sinks is usually cold air, so they have in a small container. So like right here, I might say it's like, 80% filled. But as the air sinks, it heats up. So as it's going down in elevation, it heats up. So I'm going from 80%. As it heats up, now I'm down to like 30%. The air sinks some more. Now it's down maybe like 10%. So the reason why sinking air is drier air is because it's like the container's getting bigger and bigger. So the percent that the container's filled with water is becoming less and less and less. Now, the device that we use to measure the dew point and the percent relative humidity is a device called a sling psychrometer. So here is one sling psychrometer right here. So sling psychrometer, basically it's a little device that has two thermometers on it, all right? So one of the thermometers is called a dry bulb thermometer. It's just a regular thermometer, and it's just taking the air temperature. So dry bulb temperature is the same as the air temperature. The wet bulb temperature is taken with this little thermometer right here that has a little sock on the end of it, all right? And what I do is I get that little sock wet, and then what I do is I sling it around like this. And what happens when I'm slinging it around like this, the dry bulb, the regular thermometer, just takes the air temperature. But what happens with the wet bulb one is water evaporates off the wet bulb, and that causes that thermometer temperature to go down. Excuse me. And how much it goes down depends on how much moisture there is in the air. All right. Now, this one here, one of the thermometers actually has a crack in it, so I'm gonna use a substitute one. Here is the ShimQ Econo sling psychrometer. So I just got one regular thermometer. The other one I taped some paper towel to the end of it for my wet bulb. So I'll get this wet. And we'll get some real numbers here. All right, so this is the homemade version. All right, so I'm gonna sling it around. Sling it around for like 30 seconds or so. All right. So if I look on that thermometer right there, it looks like the wet bulb temperature is about 17 degrees Celsius. And the dry bulb temperature looks like it's about 22 degrees Celsius. All right, now using those numbers, I can figure out what the dew point temperature is and what the percent relative humidity is. And to do that, have to use a chart that is in your reference tables. That looks like that. All right, so I got a dry bulb of 22 and a wet bulb of 17. So this chart's on page 12 of your reference tables. And there's two charts that look similar to each other. Right now, what we're trying to find out is the dew point temperature. All right, so what temperature in this room right now would condensation start to happen? All right, so you want to go to the chart that says dew point on top of it. Now the dry bulb temperature, again, that's the same thing as a regular air temperature. So on this one, my dry bulb temperature is 22. So I go down here to 22, and all right. Now, right here, this is where people frequently make mistakes. I do not look up the wet bulb. If you read what it says difference between wet bulb and dry bulb. So what I have to do is I'm going to subtract those two numbers. So 22 minus 17 is 5. So I'm going to look up 5 right there. All right. Again, it's the difference between the wet bulb and dry bulb. I take those two numbers, I subtract them, and that's what I look up right there. All right. So dry bulb 22, difference between the wet bulb and dry bulb 5. I now come over like this. I come down like this. And that number right there would be the dew point temperature in this room right now. So it's 14 degrees. So dew point is 14 degrees Celsius. What that means is if I was able to cool down the temperature in this room to 14 degrees Celsius, condensation would start to happen. All right. So I found my dew point. Next thing I want to find is my percent relative humidity. Right. So percent relative humidity. All right. Now to do that, I'm still going to use the same wet bulb and dry bulb data. However, I got to use a different chart. I'm going to use the chart that says percent relative humidity on top of it. All right, so relative humidity percent. Again, my dry bulb temperature, it's that 22 right there. So I come down here, and there's 22. Here it says difference between wet bulb and dry bulb. So again, what I have to do is need to subtract those two numbers. 22 minus 17 is 5. All right. So again, where this number comes from is I take the dry bulb temperature and I minus the wet bulb temperature. That's the difference between them. All right. So dry bulb 22, difference between wet bulb and dry bulb 5. So I come over like that. I come down like that. So what that tells me right now is the percent relative humidity in this room right now is 60%. So there's two ways that you can describe the moisture content in this room right now. I could describe the moisture by saying the dew point temperature is 14 degrees Celsius. That tells me more like how much actual water's in the air. Or I could say the relative humidity is 60% in this room right now. That tells me what percent of the air is filled with water. All right. So that's how you find dew point and relative humidity.